Hello everyone. In this video we will learn about the division algorithm of polynomials. Before going to the division of polynomials, let's learn about the division of the real numbers. The real numbers, when we divide one of the real number by any other real number, like we are dividing 325 by 15. We go for long division method. 325 we divide by 15, 15 to the 30, 2, 5 comes here, 15 1 ja 15, and we are left with number 10. 10 is less than 15, so we call it the remainder. So here in this division, what we say, the number which is to be divided is known as the dividend. The number by which we are dividing this number is known as the divisor. The number which comes after the division is known as the quotient. And the number which is left at last is known as the remainder, and we have to remember that remainder is always less than the divisor and it is greater than or equal to 0. So here in this case we can also write that 325 is equal to divisor means 15, quotient 21 plus remainder 10. This is the division algorithm for the numbers. Similarly, if we go for any of the polynomials, suppose we have two polynomials px and gx. Let px and gx be any polynomials. If we divide px by gx, px is to be divided by gx, and suppose the quotient in this case we write it as qx. A remainder is rx. This is the representation of the terms when we divide a polynomial by other polynomial. And same way as we have written here the division algorithm for the polynomials, we can write here px is equal to gx into qx plus rx. Here also we have to remember that rx is to be always greater than or equal to 0. And also we have to remember that degree of Rx is to be less than the degree of Gx. Then we say it is the remainder. And this is known as the division algorithm of polynomials. We discussed now one example on division algorithm of polynomials. Here we have px as x cube minus 3x square plus 5x plus 4 and gx as x minus 2. If we divide this px by gx, x cube minus 3x square plus 5x plus 4 and dividing it by x minus 2. We have to say here the first term x cube and here the first term x. If we divide x cube by x, we are getting x square. It means the quotient here we will be having the first term as x square. And if we multiply these two terms by x square, this is x cube minus 2x square. Subtracting minus plus, signs will change as we subtract them. This x cube and x cube cancel, and here this is minus 3 plus 2, it means minus x square. Take down this 5x plus 4. Now the first term here is minus x square and the first term here is x. If we divide this by this x, we are getting minus x. So in the quotient the second term will be minus x. Minus x into x, minus x square, minus minus plus 2x. Subtract plus minus, they cancel, and this is 3x plus 4. Now we find here 3x and here it is x. If we divide, we are getting 3. So every time we have to see the first terms, divide the first term of the polynomial by the first term of the divisor, that is gx, and then we can find out what should come in the quotient. So it comes here plus 3. This is 3x minus 6 minus plus. They cancel and here it is 10. Now the degree of 10 is 0 and here degree is 1. It means this is the remainder. So we can write here then that Px is equal to Gx into Qx plus Rx. It means x cube minus 3x square plus 5x plus 4 is equal to x minus 2 into x square minus x plus 3 plus 10. Now in case we want to go for verification of this, go for the right hand side. That is x minus 2 into x square minus x plus 3 plus 10. If we multiply them, first we multiply with the first term, that is x cube minus x square plus 3x. Then we multiply by minus 2. This will be minus 2x square minus minus plus 2x minus 6 plus 10. And then we simplify. This is x cube minus 3x square plus 3 and 2 5x minus 6 plus 10 plus 4. Are we getting the same? This is equal to Px, which is the left hand side. It means the division algorithm has been verified. So like this you may be asked to divide one of the polynomial Px by Gx and to find out the remainder and the quotient. And also you may be asked to find out the verification of this division algorithm. Like this we can verify it. Let's learn about the remainder theorem now. What is remainder theorem and how it is developed? We already know about the division algorithm, which says Px is equal to Gx into Qx plus Rx. If Gx is x minus a, that is a binomial of degree 1. It means we are dividing this polynomial Px by x minus a. Now suppose we are substituting in this x as a, then Pa will be equal to Ga into Qa plus Ra or not. What is Ga? Ga means substituting x is equal to a in this also, and then we will have Ga equal to a minus a equal to 0. If we substitute this value here, will we get here 0 into Qa plus Ra? And this will be equal to 0 plus Ra, or we can say Ra. So we can say if Gx is equal to x minus a, or we can say if Px is divided by x minus a, then Pa is the remainder. We can see one example here. Suppose we have been given Px is equal to x square minus 3x plus 5, and we divide it by x minus 2. Gx is x minus 2 and we want to find out the remainder. Then we can write remainder is equal to P2, and that will be 2 square minus 3 into 2 plus 5, that is 4 minus 6 plus 5, which is equal to 3. If you divide x square minus 3x plus 5 by x minus 2, you will get the remainder as 3. So we can get the remainder of this without actually dividing it. After learning about the remainder theorem, let's learn now about the factor theorem. See, suppose we have a polynomial px, and when we divide by gx, according to the division algorithm, we have gx into qx plus rx, means the remainder is rx. If we say that gx is a divisor of px, or we say that gx is a factor of px, then we know that since it is exactly dividing it, rx will be equal to 0. The remainder has to be 0. It means the factor theorem can be defined as if x minus a is a factor of px, then pa is equal to 0, because pa represents the remainder of px when it is divided by x minus a. In other way, we can also define it as if pa is equal to 0, then x minus a is a factor of px. We discuss one example based on this now, that is, find if x minus 3 is a factor of px equal to x square minus 7x plus 12. Say here px is x square minus 7x plus 12, and gx has been given as x minus 3. If we write it as 0, this gives us x is equal to 3. It means if we find the value of P3, 3 square minus 7 into 3 plus 12, this is equal to 9 minus 21 plus 12, which is 21 minus 21 equal to 0. So P3 is 0. And if P3 is 0, this implies that x minus 3 is a factor of the polynomial px. So like this we can find out whether gx is a factor of px or not. We shall discuss now one more problem on the division algorithm of polynomials, and that is from NCERT, exercise 2.3, question number 4. That is, on dividing x cube minus 3x square plus x plus 2 by a polynomial gx, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find gx. Here in the problem we are finding that px is x cube minus 3x square plus x plus 2. Gx we have to find qx is x minus 2 and the remainder rx is minus 2x plus 4. According to the division algorithm, we know that px is equal to gx into qx plus rx. See, here we have 4 terms. If any 3 of them are given to us, we can find the 4th one. And here we have to find out the one that is gx. So we substitute these values which we know. Px is x cube minus 3x square plus x plus 2 equal to gx into qx. Qx is x minus 2 plus rx, that is minus 2x plus 4. If we transpose these terms onto this side, we are getting x cube minus 3x square plus x plus 2 plus 2x minus 4 equal to gx into x minus 2. Simplifying, we are getting x cube minus 3x square plus 3x minus 2 equal to gx into x minus 2. Now we have to find gx. So we will divide this by x minus 2. So we can write here that gx will be equal to x cube minus 3x square plus 3x minus 2 upon x minus 2. So we divide this polynomial by x minus 2, x cube minus 3x square plus 3x minus 2. When we divide by x minus 2, x cube divided by x gives us x square. So the first term here is x square. Multiply x square into x, x cube minus 2x square minus plus they cancel. It comes as minus x square plus 3x minus 2. Now it goes minus x times. So it is minus x square minus minus plus 2x plus minus they cancel. And it is x minus 2. It goes plus 1 times now. This is x minus 2. They cancel and we are getting the remainder as 0. And the quotient comes as x square minus x plus 1. So here the answer comes as x square minus x plus 1. It means the divisor gx here is x square minus x plus 1. Like this, we can make use of the division algorithm to solve out the problems based on the division of polynomials. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.